Physics 2212 Lab 2 by Zephyr Smith. So the goal for this lab was to compare the point charge model and the lines of charge model for two pieces of charged tape and see which model is more accurate. And for my lines of charge model, I represented it by segments of tape, by 50 segments of the piece of tape. And we use Newton's second law and Coulomb's law in conjunction to balance and find the charges. And we also use superposition to compute the charge of the entire piece. And my results, I found that the electric force is 2.05 times 10 to the negative 3 newtons. The charge on each piece of tape is approximately 2.43 times 10 to the negative 8 coulombs. And I found that using a rod-like model is much more accurate than a point charge model. And so this is what the model looks like. We've got tape A at the bottom, which is exerting force on tape B. And the total of those forces is represented by the arrow pointing upwards, and the gravitational force is represented by the arrow pointing downwards. So for the experiment, I chose my system to be tape B and the surroundings to be everything else. So two pieces of neutrally charged tape, and I had a third piece of neutrally charged tape that was stuck to my desk. And all these pieces were equal in length. And tape B was quickly ripped off the tape on the desk, which resulted in a transfer of electrons, which made that piece of tape charged. And the behavior of the tape was examined to determine the charge, and then it was then put above tape A, and the distance at which it started to float was recorded in order to determine the charge of the tape. So this is the data I had. You can see the equations, and I got that the gravitational force is 0.0021 newtons, and the charge on the tape is 1.05 times 10 to the negative 8 coulombs. And so in my glow script, you can see I have those values inputted, and I have a function that makes an electric field based on a charged particle and observation location vector. And there's also a function that turns a line vector, and it splits it into segments and models that as a line of point charges. And then I have the two pieces of tape modeled as arrows. And then I have a for loop that basically just calculates, it goes down the line of all the segments and calculates the total force from tape A onto tape B. And then that is printed out in the form of an arrow or two arrows. So this was model 1 with my original force, and you can see that the electric force is a lot less than the gravitational force, which is the yellow downwards arrow. And so then I had a new charge using the equation for a rod, and that gave me 2.43 times 10 to the negative 8 coulombs, and you can see that they are much closer to equal. And this shows you that it is a much more accurate model. And so some discrepancies that I could have had, even though this model is much more accurate than the first one, is still not perfect because the tape was split into a finite amount of point charges when in reality it is treated as one rod. And also, the two pieces of tape probably did not have exactly the same charge, and it might not have been uniform across the entire strip of tape. So one of the questions is, what if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. And so if you model each tape as a single point charge, you basically lose out on the superposition and what that has to do with the total force. And you can see that my number when I used point charges was less than half of the charge when I used a line charge model. And these estimates differ because the line charge model is the addition of all of those charges throughout the entire strip. The line charge model is likely to be closer since it represents something closer to an actual strip of tape.